Welcome back, everyone, to another episode of Are You a Robot? This is a series where we aim to tackle some of the greatest challenges and questions that we have when it comes to AI and related technologies. The way that we're doing that is by getting some of the best and the brightest minds in their respective fields to come on here and talk with myself about what they're doing, what kind of obstacles they see within the spaces that they play in, and if there's any best practices that we can take away from it as a collective community. Speaking of community, we have got an excellent Slack workspace that continues all of these conversations that you hear on the podcast, videocast episodes. So if you like anything that you hear and you want to talk about it more, jump into the Slack community that you can find the link of below and introduce yourself. Let us know what you're working on. We'd love to chat with you and hear how you view the state of the world and what you're particularly interested when it comes to AI ethics, data governance, all of these related technologies. So, last but not least, this episode is brought to you by EthicsGrade. If you have listened to us before, you know they've been a sponsor since way back when. And they now have launched their data set. So just let me back up for a moment. If you do not know what EthicsGrade does, they are a company that rates other companies on a few different criterias, such as AI ethics, data governance. It's really fascinating to see the scorecards that they produce and they freely give out on the internet. Just check out their website to get a better view of what different companies are doing when it comes to this space. I highly encourage you to check out these different benchmarks or the rating scorecards that they have produced so you can see where different companies add up, not only against each other, but in the greater scheme of things. Go check out the website. It's ethicsgrade.io. You can also find a link to that in the description below. And without further ado, let's talk with Fiona. This was an amazing conversation around data quality, and we really got into it. Data quality is so important for so many things, as you will hear. Fiona helped me understand that. There's also an important Google paper that we talked about quite a bit in this episode, which you can find a link to below. And of course, if you like what Fiona is doing, check out more on her by following the links below. That's all we've got. Let's hear what Fiona has to say.
Are you a robot?
Excellent. So I think we should probably start by hearing a little bit of background information on yourself and how you got into data science and ML.
Sure. So my background's firmly within the technology side. I have a degree in computer science and a PhD in applied machine learning, where we were looking at integrating diverse biological omic data together for the prediction of protein-protein interactions. My career is not necessarily a linear path. So my background's both in academia and in industry. So from industry, I was a web developer at Intel and a design company called Design by Front, and also a senior software developer at a company called PathXL, who specialised in virtual microscopy. And I think what's interesting from industry, this is where you really learn your trade. You learn how to program, and you learn how to program at a production level. And all those good practices from software development in terms of testing, coding practices, agile development, and so on. I really got those skills from the industrial side. From the academic side, it's it's very much applied AI, which I'm really, really interested in. And that's been applying evidential reasoning to help make decisions whenever you have data which is really messy, it's conflicting with one another, but yet you need to make a decision from it. And we did some work around that using Dempster Schaefer in the aerospace domain. And another area of research which I'm really into is networks and multiplex networks, and using networks to integrate diverse data together. So going back to the PhD work, my time at as a lecturer at university, we were integrating together omic data for disease prediction using networks. And what I really like is when disciplines combine. So it's whenever computing combines with biology, medicine, aerodynamics, and so on. I think that's where the magic really happens. And then I suppose what underpins everything is having that rigor in developing systems, especially machine learning systems, and the importance that data plays in that process as well.
So let's talk for a little bit about the quality of data and how important that is. And I think people are starting to wake up to that right now, especially because, as you, I'm sure, are well aware, who is it, Andrew Ng went on and he talked about how important it is in machine learning. And then everyone said, yeah, it's incredible. It's so important. And so I think a lot of eyeballs turned to the data quality issues that we have. And so I'm wondering, in your experience, and I really love what you talked about with your experience, taking like the best of in the industry and figuring out how to really get those best practices in operationalizing and productionizing, and then also taking this academic point of view and then finding those places where different worlds collide so that you can create something new. But when we come to data quality that you speak of, what are some ways that we can apply rigor to the data process?
Yeah, so super question, Demetrius, and I agree. I'm a big fan of Andrew Ng, and I love the fact that he's come out and has said we need to be more data centric and less model centric. And I don't know if you've seen the recent paper by Google as well, which it says everybody wants to do the model work and not
So good.
the data work. And it's not often you get really excited about an academic paper, but whenever I seen that come out, it was like, excellent. This is this is what we've been trying to say for a long time. Because up to now, it really has been, the big deep learning models, which are the star of the show. So everybody wants to talk about Google's BERT or OpenAI's GPT-3, and not so much on the data side. And in the recent Google paper, I loved the way they phrased it, in that they had said that the data side is viewed as unglamorous, and because of this, it's undervalued work. And if I can quote from the paper, because they've succinctly said this so well, is that the data largely determines your performance, the fairness, robustness, safety, and the scalability of AI systems. Yet, in most organizations and practices, fail to meet basic data quality standards, with a focus instead um, on the model side. And I think by taking a look at data management, standards, reproducibility, traceability of that through the process, you're going to have better performance from your models. And actually also from a broader point of view as well, it's understanding the impact that your models have on the people who are using them and the society in which they're being applied as well. So I'm really excited to see a light shone on this area. And it's an important part of the ML ops process. And I know you're a big champion of that as well, Demetrius. So I think they go hand in hand.
Yeah, completely. And that paper is fascinating to me. I love what you mentioned there about it's the unglamorous part. And then they also talk about how the part of or the people that are doing the job of labeling and um, and categorizing the data, they are severely underpaid when you compare them to data scientists who is doing the modeling. And they also bring up a point that I think is fascinating. And I'd love to just get into this paper real deep with you if it's all right, because I'm glad you brought it up and I think it's an incredible paper. The thing that they brought up that I thought was fascinating was that data is never raw. And maybe you can go into that a little more. I mean, it seems like even before we collect the data, us deciding what data is important and us deciding how much of that data we need and
Mm-hmm.
what we're measuring it in, all of a sudden now it's tainted with our biases before we've even gone out and collected it. So them talking about how the data is never raw was an eye opener for me.
Yeah, exactly, and that leads also to this need for diversity in teams who are building these systems and also collating the data then as well. So it's having that focus or even documentation as to why you're going to you have to go out, you have to create a data set. What values are you going to measure and why? How much are you going to collate for it? And is it representative of the problem that you are trying to model further down the line? And what's interesting, so this paper talked about high stakes AI, so AI that's used in the medical domain or prediction of whether somebody gets a loan or not. And what was particularly interesting from the medical domain is that it was the lack of value placed on practitioners who were gathering that data at the coal face as such. So, for example, within a hospital setting, it was asking nurses, doctors, on top of everything you already do, collect all this data, please. And then maybe without the focus on having very specific, detailed approach to how to collect this data to ensure that there is consistency in the process. So that's the first side. And then the second side that comes up as well, and you've talked about, Demetrius, is the labeling of data sets, which is also a very important task, and a task that is often outsourced and not given particular value associated to it. So this is a time-consuming, laborious task, and I think whenever we're talking about labeling of data sets, I don't really hear it talked about that much in the general ML side of it. Yet within this paper, the researchers has said that between 25 to 60% of the overall cost of a machine learning project is actually at the labeling phase. So why don't we focus a bit more on this? And then, as the Andrew Ng has said in the taking a model-centric view, he also went back to the labeling side as well of data sets and ensuring that there's consistency in the labels applied, as this can have a direct impact on the predictions made by the model further downstream. And he actually used a really nice use case, and it was detecting defects on steel, I think, rolls. And it showed the case where, okay, let's focus on the model side and tweak the hyperparameters and see how we can improve the performance and marginal gains. Whereas going back to the data, looking at the consistency of the data, the quality of the data, the consistency of the labels, and fixing those noisy labels, they were able to, I think, increase from a baseline of 73 to up to 90% accuracy, just looking at the data alone. And I love that because it's a very
Huge.
clear example of, just go back and fix your data. And I think it also talks to, AI isn't magic. It needs good
Yeah.
quality data to learn from and to identify patterns from. And I definitely do see that coming through more and more now. Even
Mm.
researchers in the medical domain going back to data sets which are used to, big open data sets used to train lots of models, going back, looking at the consistency of the labels and fixing them again.
Yeah, and what you're talking about, it reminds me of all of the drama and controversy that happened around the open AI GTP3 or GPT. I can't remember which one it is ever, but I think people know which one I'm talking about. And the inability for it to say anything without violence when it came to talking about Muslims. And there was all of this controversy about how just openly biased it was, um, and racist in a way. So that, like you said, it all comes back to the data, and there's so much that we have, so many cliches around that, right? Like that we've heard a million times, and everyone likes to talk about it, especially in machine learning. The ones who are the machine learning engineers or the data scientists, they will tout all day long garbage in, garbage out. Or you will
Mhm.
see people posting about it continuously on LinkedIn that, well, a data scientist's primary time, or the data scientist, 80% of a data scientist's time is taken up cleaning the data and labeling the data and doing stuff with the data. And what you mentioned, and the paper
Yeah.
also mentioned, which is so important, is that it's like they have to speed through that part. And
Mhm.
that just sets them up for failure because it's not seen as an essential part. So then you have to go through it really fast just so you can get to the modeling, and then you're trying to do
Yeah.
something with the modeling, and like you mentioned before, you're trying to create magic, but your foundation isn't there. So it really shows the
Yeah.
importance of that. Now, I wanted to ask you about the idea that this paper brings forth, which is like the cascades. And maybe you can explain to myself and the listeners what exactly that is, what they were talking about when they were saying the cascades.
Yeah, so it was about the, for high importance or high risk AI, how having poor data quality at the start really has a knock on effect from everything in down downstream analysis. And and actually, one of the examples that they had used for this was the IBM Watson Oncology. So the idea of data cascades in that particular example was um, a lot of there was a lot of hype around this IBM Watson Oncology with the um, in predicting outcomes for cancer. So it had learned from, well, it should have learned from patient data and so on, and provide information to clinicians on treatments and so on. But at the start of the process, the data gathered was data that was representative of patients as opposed to actual real patients' data. And whenever it was applied in a clinical setting, it was giving completely erroneous and dangerous predictions, which had an impact on people and on people's health. And if there wasn't a human in the loop to address it there, you could have been getting wrong treatment. So that really shows the cascade from I suppose, not enough effort put into the data at the start, and then the impact that actually has on a person downstream. And I think for that particular example, it wasn't just the data side of it. It was like, how did this get out the door and put into a clinical practice and only be picked up at that stage? And where was the AI framework around it? Where was the testing around it? It's that whole system view approach, and
Mm.
with the same thing with the open AI GPT-3, whenever it was released and used, why is it only then that these particular issues are being picked up? Instead, we should have a more robust system that is looking for, it's looking for bias, it's testing for it, it's looking at the system as a whole. It's not relying on a data engineer, an ML engineer randomly picking up an error, that there's a systematic process there. So whenever it is out in production, that you have caught hopefully most of these serious issues. And I suppose that's due to a rather nascent stage of ML ops at the minute, and it's really interesting, and it's really interesting to see it mature as well. Just like software development has been maturing over the past 30 years, we're hopefully going to see that now with our ML ops side of it.
Yeah, that's such a great point that you make. And it comes back to the diversity involved and looking at it as a system. Someone that I interviewed a few weeks ago, Chris Berg, who's the CEO of a company called Data Kitchen, he was talking about how, and this fits in directly to what you're saying, is how everyone who is working in the machine learning process or AI on data products, basically, they are responsible for the results, not just the piece that they've done. Because otherwise, it's very easy to pass the buck and say, oh, well, I just created the model, but I wasn't the one who had to figure out the bias involved, right? Or I just set up
Mhm.
the pipeline. I wasn't the one who was creating the model that was biased. And so then everybody can stand off and say, well, it wasn't my fault. But when you're looking at it like that, with that systems approach and saying, hey, you're responsible for the result, then everyone takes ownership and they take more accountability for it. And I think what you're talking about when it comes to the sorry, my daughter just walked in case you can hear that. Um,
That's lovely.
where was I? What you were talking about with the systems approach and being able to look at it in a holistic way and trying to spot things before they're out in production. I'm just going to quote from another person I interviewed 2 weeks ago, Alfredo, who was talking about this testing part. And in his mind, he felt like you can never write enough tests. And what he was a big proponent of was you want to catch something as early as possible, because the closer that you catch it to production, then the more expensive it is going to be. And you catch it
Mhm.
while it's in production, then it's going to be expensive because of the reputation that you just destroyed, or because of the trust that you just lost, on top of all of the resources that you have to deploy when you go back and you try and fix that problem. But it seems like right now, the mantra for us, sadly, and it's probably because it's so new still, but it seems like the mantra that we keep asking ourselves is, how did that get put out into production? And so it really is that moment that we're at right now. And like you said, it could be just because it's such a nascent, it's so new that we don't have the grasp on what needs to be done and how to write tests and how to properly analyze the data or even focus on the data. I think that might be something that we can talk about too, is
Mhm.
how can we put more focus on the data besides just having people like Andrew come out and talk about how important it is.
Yeah, and I think we need to be able to shift the conversation from, yeah, as you said, Demetrius, there's the we spend 80% of our time with the data. Haha, let's get to the bottle
Totally.
part. Um, why don't we say, okay, 80% of our time is spent in the data. How can how how can we actually apply machine learning to make our lives easier at this stage? We know that it's not easy. It's not easy work. So that's make this an important part of our work, and that probably involves education and communication across all different levels within either a company or within academia as well. And actually, this is what we focus on in our work is, okay, how can we improve the manual processes around data and data quality. So we've been looking at things such as labeling data sets and how to make this more systematic. I don't know if you've ever had to label a data set before, Demetrius.
I
You
have
might have
not.
got away
Yeah.
with that task.
Just give it to the interns.
Well, let me.
No.
Well, myself and my team were involved last summer in labeling a data set for one of our entity matching models. And let me tell you, it's a really boring process. And you just don't want to do it. You just want to get on to something else. And that's where mistakes come in. And you really do need a specific outline to say why you label something a particular way. So we were labeling was an entity a match or not. So machine learning can be applied there. So instead of a subject matter expert labeling 10,000 examples or instances for the data set, um, let's use active learning or pseudo learning to prioritize those real tricky edge cases that a classifier has difficulty with. So that's one way that you can apply machine learning, and you're reducing that volume of manual review for a reviewer. And then you can employ really simple techniques such as okay, so human in the loop's really important for us in the work that we do, for informing our models and providing context for our models as well. So we capture information as to, okay, you've labelled this in a particular way. Can you tell me why you labelled it in this particular way? And documenting that and capturing that information is really important in terms of traceability and also explainability further downstream whenever your models are making predictions. So it's bringing in that good practice in terms of documenting as as you go along. And then you can apply data quality metrics to a data set that you've constructed and labelled. So you can perform checks such as consistency, is it valid, and so on, and through to, okay, looking at the label cases if we're doing supervised learning, maybe looking at things such as measuring fairness and bias, which I know are very hot topics at the moment. So doing simple checks as to, is this a representative data set? Is it a balanced data set? So we know how that can have a knock-on effect in some classifiers. You can measure the consistency of the labels as well. And having those metrics provided to you will help you go back, because this is an iterative process, and maybe focus on improving the consistency of the labels, or identifying at an early stage, do you know what, I don't have a representative example here. In fact, I've got a
Mhm.
data desert for a particular cohort which are not represented at all within this data set. I need to go back and fix this again. And we are seeing that coming through within industry. So IBM have FAIR AI 360, where it proposes a number of approaches to test if your system's fair, or where identifying unintentional biases and unintentional consequences of your system. So maybe having labels such as age and race and so on as labels within your data set, and then being able to test a model's performance against that. So you're capturing this at that stage, as opposed to out um, out in the field. Um, and I know there's a lot of work being done around this area, because even defining what is fair and what bias looks like is still in its early stages. But
Yeah.
at least we're thinking about this now, and we're trying it out, and we will have to keep learning as well.
Yeah, it's funny you mentioned that because we had Browne on here, who is an algorithm or AI. He audits AI systems and machine learning systems. And the first question I asked him when he came on here, I said, "Do you think that your job is going to be ever outsourced to a machine learning algorithm that is able to audit itself, basically?" And he said, "Well, right now, it's really
Hmm.
hard to say even what we we don't have the process in place. It's so complex that if we as humans don't even know how to do it, how can we outsource it to a machine at this moment?" And there are a few things that you mentioned before that I just wanted to get your clarification on, because I think they all fly together and they're a little more technical, but it is important for people if they're listening and they were wondering, what does that mean? There was something you talked about, supervised learning, and then there's human in the loop. These are just some terms that maybe you can explain to us what they mean, and then explainability. I think those three kind of fit together, and they are
Hmm.
important to understand for this greater conversation that we're having.
Yeah, sure. No problem, Demetrius. So this is nice. I get to put my lecture hat back on again and talk about supervised and unsupervised learning.
Yeah.
So yeah, so there's different machine learning approaches. You can have supervised learning, unsupervised learning. There's semi-supervised learning, reinforcement learning. Um, and for supervised learning, whenever we're talking about that, we're talking about a model that learns from labeled examples. So, for example, say you've got a piece of text. Does this have a positive sentiment or negative sentiment? And you provide the labels, and the model then learns patterns from your features, and it uses this information to basically discriminate between the classes that it's trying to predict. And then this differs then from unsupervised learning. So you may not have a labeled data set. In that case, you could use unsupervised learning, where you are trying to maybe identify clusters or groups of data that that are found together. So, for example, in marketing, maybe certain types of clusters which represent people who represent like different things that you're trying to sell. Um,
And
and then
unsupervised learning, correct me if I'm
human,
wrong, is also really popular with games. Like if you give a machine learning algorithm a a car that it has to drive and it has to get to from A to B, and then you just let it go and let it learn, teach itself basically is how it works, if I'm not mistaken.
yes. So yeah, that would probably fall under the reinforcement learning. So yeah, it's really a really nice way to explain that is like like a kid beginning to learn. So I've got two boys. They had to learn to walk as babies, and it's basically trial and error, working out, moving from A to B, and what works and what doesn't work. So yeah, that the area of reinforcement learning is really gaining traction at present in ML, which is really super interesting as well. That's essentially where you have a human to help direct your machine learning. And an example of that in our work is in our entity matching. So entities can be people, they can be places, they can be corporations, and one of the problems that we undertake for our clients is matching entities together to give a single view. Um, and what our model does is that it tries to predict, is this entity the same as this entity? So, for example, Demetrius, you could hold a number of different bank accounts, but you could have a different address because maybe one of your addresses was outdated, and you're trying to figure out, is this you or is this somebody completely different? So we have a model that has a number of match features that it uses to make a prediction. And then it provides to a subject matter expert, hey, I think this is a match here. Do you agree with this or not? And what we're doing is that we're capturing the subject matter's expertise, um, as to whether or not it's a true match or it's a false prediction. So we're using their expertise to add to our training data. So then we can retrain our model again, then based on that. So it's a little pulse check to make sure that what is being predicted is actually accurate as well. So oversight of humans within the system. Oh, and the third one was explainability. So, yeah, this is a really hot topic at the moment in terms of explainable AI. How is that related to transparency in the processes as well? So, explainability can mean different things to different people. So, explainability to a data science, machine learning engineer could be very different to explainability to a person who's getting a prediction at the end of 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 a system. But yet, it's still very important. So, we want to explain why a model made a particular prediction, and there's different techniques that can be used to do this. So you could have a very simple model like a decision tree or a linear regression model, and these are known as transparent models because we can see from data being input to how it was prediction was output. We can see how that happens. You have models such as deep learning neural networks where you really don't have a clue. No idea what's happening in there. There's synapses firing. Don't have a clue what these activation functions are doing, but I get a result at the end. But there are ways to probe these systems to help us explain why a particular prediction was made. So we have things such as using like SHAP values and LIME. And let me get the nice definition of LIME here. Because it's very good at sort of giving you an idea of what features drove a prediction. So you mightn't be able to open the box completely, but you can give it a push to see, okay, at a local level, what were the features that particularly drove this prediction? So LIME is local interpretable model agnostic explanations. You can see why they've shortened it to to LIME. And what it does, it sort of gives us an idea on feature importance. So, for example, say you've got a model that's predicting a particular outcome, and postcode is one of the the key features driving that prediction. You, as a human subject matter expert, can say, actually, no, that feature should not be driving the prediction within this model. So it gives you an idea of what's happening in there and maybe where spurious correlations are happening then as well. And then you've got explainability in terms of what's happened the whole way through the process here. So what's the provenance of my data set? Where did it come from? What version is it? How was it made up? Can you give me some information about metrics around fairness, bias, representation, and so on, where it was tested, through to how was the model built? What was it trained on? What's the size of the data set that it was trained on? And what level of performance does it get at the end, and so on. So it's explainability from different approaches, and that there's lots of techniques out there to help us with that. It's still quite a new field, and I think it's really been talked about and pushed on with the area of AI ethics and explainability of models. Because if you're refused alone, you want to know why you've been refused alone. And if we look at current approaches, if you're refused a loan, you'll get information as to why you're refused a loan and what factors you were refused a loan on. So it's building that explainability and transparency then into the process.
Completely. And this is where we hear a bit about the black boxes, that this algorithm or this model is just making predictions, but we have no idea why. And we're really trying to get away from that because it is so dangerous and it is so detrimental, especially when we're talking about high stakes machine learning. And if a model can't tell you why it's making its predictions, then you have to blindly trust it or throw it out. And it's not an ideal situation. So there was something that you said that I thought was fascinating a few questions ago. And thank you for explaining all of this. To me, it's also very helpful just to hear it. And I learned something there too. So the thing you said, though, that I found very interesting was when you mentioned data deserts. And you were talking about trying to get machine learning to look at or label different data sets so that it takes the brunt off of the humans. And you also said that sometimes you may have just slices or whole sets of data that, or whole sets of people or whatever it is that is included in the data set that's not there, and it's a data desert. And maybe you can talk about the data deserts a little bit more. And then also, have you seen applications or programs or tools that help you identify those data deserts? Is that what the IBM tool you were talking about with the fairness, is that part of it?
Yeah, so the data desert's really interesting. So it's either a data set where data about maybe a particular subset of the population just hasn't even been considered or encoded within the set, or it may be a particular problem area which you're trying to make a prediction on, and there's just no data there on it, and you have to go out and gather that data. And I think the whole side on the whole representative samples and having the right data there at the start. Again, it goes back to your model as a system, but it also goes back to having the right people on the team to see this. So, like personally, as a machine learning practitioner, I'm not very good at understanding risk from a business point of view. So instead of just me going off by myself trying to work that out, having that cross-disciplinary approach where you have someone who's a specialist in risk, knows the business domain or the problem domain that you're in, and shines a light on that. There was a recent article that I read in the Financial Times at the weekend by an economist, Tim Hargrove, and he was talking about groupthink, and I actually like some of the content in terms of you've got a load of smart people in a room and you still make a terrible decision. How do you prevent that? I think this is similar to whenever you are constructing your data set. You've very smart people building these processes and models and so on, yet we're still making mistakes. How can we prevent that? And one of the ways is having a diverse group of people in the room making those decisions as a first one. And a second one, to have a sort of devil advocates group, a challenge group to say, okay, have you thought about this? Have you thought about that? And really push against what's what's being done. And I think that's maybe one way where we can apply techniques to improve building data sets which are representative and challenging ourselves as well. The IBM FAIR 360 is a way of looking at like a systematic metric approach. So it's very interesting. You're trying to encode values programmatically. So it's what does FAIR look like? Can we use information on age, gender, and so on? Have these as labels and use these to test to see if our model is being fair to these to the different subsections in society, right through to are these vulnerable groups encoded within your data set, and if not, this is going to have a detrimental impact to them. An example which I come into from time to time is voice recognition systems. And this has been backed up with research from Washington University. So they did a study, it was a while back now, it was 2016, 2017, where they were basically come to the conclusion that, if you're a male, you're 70% more likely to be understood by a voice recognition system. And it's a double whammy for me because, number one, the real thick Northern Irish accent, and number two, a female accent as well. Not a hope of any system understanding what I'm saying. And it all comes back to the data that's being collated, the data that the model has been trained on. And then also, I suppose, the cleanliness of the data. So often you're training data, it's very good, high quality data, and it might miss, common noises that are in normal day to day lives. So I don't know if I've covered that off, but it's a very interesting one, and one that I hit every day, essentially, whenever I'm trying to ask for music to come on.
Yeah, it's funny you should mention that too. We had a man named Lewis Bird on the first season of this podcast, and he was talking about how he wasn't understood by his voice assistant. I think it was Brixby, the Samsung one that he was using, and he was saying that he realized after his wife spoke to the voice assistant at some point that if he changed his voice and he put on what he called his white voice, then the voice assistant understood him impeccably. But if he just spoke like normal, it didn't pick up half of the things that he was trying to say. So I feel for you. Maybe you have to put on your American accent and speak in a little bit deeper of a voice, and you'll be better understood. But
Yeah, I'll try that
yeah.
after this to see how far I get.
Exactly. But there's something else that I wanted to bring up that I think is really important to mention when we are talking about this data quality and then the implications that it has throughout the life cycle of machine learning and AI products and data products in general. And this comes from the article we were talking about earlier on how really when you look at this model centric view and you're looking at everything like the model is the star player of the AI product or the machine learning product, then what they have been doing and what you see when it's very high stakes is the model accuracy is something that they need to really make sure that they have within 1%, or sorry, it's like 99% model accuracy, right? They can't have a 1% variability or more than 1% because you're looking at someone's, the example they used in the paper was you're trying to determine if someone has retina cancer. And if the model says they don't, and then later it is true that they do, they go blind, and it's very harmful, and it has very impacting events. And we've mentioned many of them, right? Like if you're asking for a loan, or like we've seen in, I think it's Florida, where they're deciding who gets out on bail or how long someone goes to jail for.
Mhm.
These are high impact situations and high stakes ML. And the point that they make in the paper, which I think is really important to highlight, is that when you're looking at it through a model centric viewpoint, there's a tendency to cut corners on that model and making it be 1%, or sorry, 99% accurate, because the data, so it's like if the data isn't the best but you get 1%, 99%, I don't know why I keep saying 1%, but if the data isn't the best data and the highest quality, and then you get this 99%, the problem there is that it doesn't matter, because the data that you've done all of this hard work on, or that isn't properly cleansed or isn't the highest quality, it's like you're cutting corners. I'm not sure if this is making sense to anybody but myself, but I think the idea here that I really wanted to get out is that we have to be very, very rigorous with the data because of all the implications downstream. And when we're looking at creating this
Yeah.
model, and then you have something that goes out into production and you think it is
Mhm.
99% accurate, and really you're highly mistaken.
Yeah, and yeah, I think this is the crux of that paper, is that and that cascade effect, as well, Demetrius. So having that data quality, a high data quality that goes through all of your model process, coupling that with your testing, coupling that with your ownership as well, ensuring that you have adhere to regulations, especially in areas which are highly regulated, like health and finance and so on. That you've got all that right before you make predictions which will have a direct impact on a person's life at the end of the process. And it's really important for us not to lose sight of that. And I think we're seeing that impetus being brought in now. So we're saying, because at the moment, what's driving us to do all this hard work on the rigor and the data quality side? Well, now we're seeing regulations coming in. So in our area, we're in finance. So BCBS 239 is in, and it's saying to the financial institution, you need to have good data quality here, or else I'm going to slap you with a fine. So that's one impetus. Then another one is reputational damage and trust, which you've already touched on as well. And then the third one is law. So you get this wrong, there is lawful implications here as well. And this is where we need regulators and lawmakers within this process. And I know it's so difficult because it's new and we're still learning, and technology is changing, but we need to do something. And I know that there's new draft guidelines and a law from the EU side on AI. And it's quite interesting because they're coming at it from a human-centric point of view and from a risk point of view as well. So it'll be interesting to see how that evolves. And I was listening to some of your previous podcasts, and you've had some great experts on talking about that specifically.
Yeah, it's interesting that you highlight that from it's looking at it from a human-centric perspective and a risk-centric perspective, but not from the data-centric perspective or the model-centric. And so this has been an excellent conversation, Fiona. I could continue talking with you for hours on end, and especially about the data quality, which I know is such an important piece. And it is a little bit, it has a crossover with the ethics and the technical folks. And I think it is one of those pieces that it's easier for those who aren't as technical to understand in a way that makes sense. You don't have to know some crazy math to be able to know that if you're collecting good data and then you're using that and you're cleaning it and you're doing the right things to it, it is going to have major implications and it is going to be hugely beneficial, and likewise vice versa. So I have one last question for you. As you've listened to other episodes, you probably know what's coming now. Fiona, are you a robot?
Well, certainly not. Uh, but thank you so much, Demetrius. I've really enjoyed our conversation today, and great respect to the work that this podcast did, and also your work on the ML ops side as well.
Oh, thank you, Fiona. Have a great day, and we will see everyone in the next episode. Take care.